Hey, what's up guys? Today I'm going to show you how to find the area under a density curve using z-scores. So first let's review what is the density curve. It's when you have a bell-shaped curve just like the one I have here. Mine is not great, but it looks like a bell-shaped curve. Right in the middle of that bell-shaped curve we have the mean of the population. So it is cut in half, or you can say that this mean will be at the center of the density curve and the density curve will be symmetrical, which means the left side equals the same as the right side. It is symmetrical on both sides. The z-scores is the distance that you are away from the mean. So when you look at the x or the horizontal axis, the one that goes from left to right, kind of like the x-axis if you think about the coordinate plane. So we have the horizontal line, horizontal axis. The center will be right in the middle of the density curve. This, whatever mean we have for the population, the z-score will be 0. So that's your starting point. On the right side of the density curve, you have the positive z-scores, and on the left side, you have the negative z-scores. So you can have, or you can be one positive z-score away from the mean, that's to the right, or maybe you guys can be one negative z-score, that's on the left side of the mean. So that tells you the location you are in that density curve. Now the z-scores can also help us find the area under the curve. Now what does the area represent under the curve? The area is the amount or proportion of the population for this specific distribution. So your population can be people, can be animals, can be measurements, height, it can be weight. So when you guys are looking at the proportion, how many people are in a specific location of the density curve, that is the area under the curve. So if you think about the whole area under the curve, I'm just going to shade the whole area under the curve. That means that this area is 100% if you shade everything under the curve. So in a density curve, the problems will be you trying to find the area under the curve from one point to a second point. So I have an example here. The example that I have, it says that we have a normal distribution, and it's very important to understand that this distribution is normal, because when it's normal, that means that we have a symmetrical bell-shaped curve, just like the density curve. It is a density curve, and the mean or the center will be that mean of the distribution. So the notation that we use is n for normal. We have 304 for my example. The first number is going to be your mean, comma, and we have the standard deviations or sigma. Now the standard deviations is also the distance away from the mean. Now we have to use z-scores in order to find the area under the curve. So we need to standardize the scores when we are looking for that area. Now to understand the relationship between z-scores and the distribution of the population, well, I have the density curve here, but notice that I'm not using 0, +1, or the -1. I'm using the actual measurement they give us for this distribution. So they say that the mean or the center is 304. So at the density curve right at the center, I'm just going to draw a dashed line right there. Right at the center is 304. On the right side, we know we are going to go to positive z-scores. So I am going to add these standard deviations, because the standard deviations is also how many units you are away from the mean in standard deviations. So it's related to z-scores, but when you use standard deviations, you guys are going to add whatever value this is. So from the center, 304 plus 8, that's going to be 312, and that's going to be one standard deviation. If I add 2 standard deviations, so I'm actually adding 8 plus another 8, so it's going to be total of 16. So we have 304 plus 16, that's 320. And if you guys go 3 standard deviations, which means 3 times 8, so that's going to be 1, 2, 3, that's going to be 328. If you guys go to the left side of the center, well, that means you're going to have to subtract, because these are negative standard deviations when you guys go to the left. So you subtract from the center 304, that's going to be 296. Subtract 8 again, because that is the measurement they give us for this distribution. So you subtract 8 again and 388, and subtract 8, and that's going to be 380. So from the left, from the center to the left, this is 1 standard deviation, 296, 2 standard deviations, 288, and 3 standard deviations. And you can say negative, because we're going to the left, 1 negative standard deviation, 2 negative, 3, 288, and then 3 negative standard deviations. So how do you find the actual area under the curve? So I have a question. I want to know what percent is between 305 and 325. So in reality, this is what we're asking. I want to know what is the area between 305. So I know 304 is here. So 305, let's say, is right here. So I'm just going to label that as 305 all the way to 325. So here's 320. So I'm going to say 325 is kind of right there. And this is just an approximation. It's not going to be exact. But this is 325. So I am looking for the area between this value under the curve, 305, all the way to the 325, which is here. So this is the area we are looking for. I want to know what that is. Okay. Now I'm going to use C-scores. I need to standardize the scores in order to use the calculator and find that area. So to standardize, we have a formula. And the formula for C-scores, you are going to take the measurement that you want to standardize. So that's X, the measurement, minus the mean of the distribution divided by the standard deviation. So when you guys set up your formula for C-scores, I want to standardize the 305. So I have the 305 minus the mean of the standard deviation, which is here, divided by the standard deviation. So 304 is the mean, sorry. So this is the distribution, 304 is the mean. So you have 305 minus the mean divided by the standard deviation, which is sigma, and that's 8. So for this one, we get 2 decimal places. You round. Every time you look for C-scores, we round to 2 decimals. That's going to be 0.13. And the next one is 325. So I'm going to standardize 325 minus the mean of the distribution divided by the standard deviation, and that's going to be 2.63. So finally, what does this mean? Well, if we use C-scores, I'm going to give you guys a visual of that same density curve. So notice that here I have the question mark. What is that area? So this density curve can be also written as this one using C-scores. The mean will be your 0 C-scores. That's what it when you try standardize the mean 304, you guys will get 0, because if you substitute 304 minus the mean, which is 304, so 304 minus 304, that's going to be 0 divided by 8, which is standard deviation. That's going to be 0. But we are looking for the area between 0.13, which is right here, and 2.63. So same thing. I want to know what is this area. So the two density curves that you guys see on the screen, let me move this a little bit down. So this one, we're using the measurements of the distribution, and this one using the C-scores. It is the same area, but we're using different measurements. Here we have C-scores. Over here we are using the measurements of the actual distribution, the mean with the standard deviation. How do you guys find that area using the calculator? So in the calculator, you guys are going to go here to second vars. In blue, you guys will see the distribution. So you guys look for that second distribution. And to find the area under the curve, we use normal CDF. So you choose that option. And it's going to ask you guys for the lower bound and upper bound. I have different numbers, so I have to change mine. So my lower bound is going to be the lowest C-score. So I have 0.13. And the upper bound, so my upper will be 2.63. So let's do that right now. We have 0.13, and the second one is 2.63. Now for the mean, remember that we're using C-scores. So your mean will always be 0 for C-scores, and the standard deviation, the distribution has standard deviation of 8. But as a C-score, that's going to be 1 standard deviation. So I'm going to use 1 for sigma. So the mean is 0 and the standard deviation is 1. That is in C-scores. You can say C-score language. So you guys go here, you paste, and then you press enter, and that's going to be your area under the curve. Now when we're looking for areas, we usually round to 4 decimal places or 4 numbers after the decimal. 1, 2, 3, 4. So this one, the 0, doesn't round up, so it stays at 0. So my question mark will be 0.4440. So that is the area. Or as a percent, you can also say, well, the area under the curve is 44.40%. That's the proportion. That's the actual number or percent of the population between 305 and 325. So this area, the proportion of the population that is between 305 and 325 is 44.40%. Now, this one can also be considered as the probability, because probability, it is a proportion, it's a fraction. You guys can find the probability by dividing what you want, the number of outcomes you want, divided by the number of total outcomes. So you can say that the probability between this value and that value, the probability between 305 and 325 is 44.40. If you guys like my videos, make sure you guys click that like button. You guys can subscribe to my channel to watch more videos, and I'll see you guys later.